So what we're working on today is we are working on our third type of factoring. And it's referred to as the difference of two perfect squares. But a lot of times we refer to it just as dots. We just kind of shorten it down to make that it's dots. A couple of key things in here is the fact that it says difference. The difference means that it's a subtraction. So you've got to keep in mind that it has to be a subtraction problem. You're going to see a lot of problems that look like they're going to be a dots problem, but they're not because there's an addition sign as opposed to a subtraction sign. So that's one of the main things to look for. The other thing is that it's two perfect squares. So we're going to take a look and try to refresh our memories as to what a perfect square is. So looking at our examples here, to find, 49 is a perfect square. So what we do is we take the square root of it and we get a 7. So 49 is a perfect square because when you take the square root, you don't get a decimal, you get a whole number. So for our next one, when we have a variable, if your exponent is even, so even exponent, that means it's a perfect square. So looking at our example here in B, when I take the square root of 16 gives me a 4. My exponent, you want to divide it by 2, so I would get x to the first. So 4x would be our square root there. C, this would give us 8y. And D, that would give us 10y. And they wanted us to write these as a monomial squared. So that would be 7 squared, 4x squared, 9y squared, 10y squared. That's how we would get those numbers again. So again, you have to make sure there's subtraction. You have to make sure there's only two perfect squares. So if we take a look at our next grouping down here, a lot of things look like perfect squares, but they're not actually perfect squares. So if we look at letter A, 9 is a perfect square, and my x has an even exponent. So yes, this one would be a perfect square. If we look at B, a lot of people want to jump and tell me, yes, that's a perfect square because they see the 4. But that exponent up there on your x, that's a 1. That's not a perfect square. So this one's not a perfect square. Let's take a look at example C. So here we have x squared. That is perfect, but our 8 is not. So the whole thing is not a perfect square. And then if we look at our last one, we got a 25. And yes, 25 is a perfect square. All right, so what we're going to do down here is we're going to first multiply these out. So we're going to practice the skill of our double distribution. Distribute my x, so I get x squared times plus a 2x. Distribute my negative 2. Combine our like terms here, which actually what ends up happening is your middle terms cancel each other out, so we were left with x squared minus 4. So let's do the same thing here with the next one. So I'm going to distribute my 3x, so I get 3x squared. That should be a minus. Minus 3. Distribute my 1, so I get plus 3x minus 1. Again, our middle terms cancel each other out. I'm left with 9x squared minus 1. So for our last one, distribute my 4y, so I get 16y squared plus 20y. Distribute my negative 5, so I get negative 20y minus 25. Our middle term cancels itself out, so we're left with 16y squared minus 25. So these three answers that we got here, these are all examples of what a dots setup should look like. Each of them has two perfect squares for terms. 1, 2, 1, 2, 1, 2. And there's a subtraction sign in the middle. So this would be a dots factor. So when we go to factor it, our rules would be the same. Our sign here is the subtraction, so your signs would be different when you when you factor. And we're going to end up getting here where your parentheses are exactly the same stuff. It's just one's a minus, one's a plus. Your terms are the same in there. Same thing with here. Your terms are the same. It's just one's minus, one's plus. And same thing with our last one. That's what it's going to look like when we factor. So when we go to do our check, your middle term should cancel. You should get a 0x in the middle. So let's take a look at our examples. For our setup, You're going to start with two sets of parentheses, one's plus, one's minus, and it does not matter which order you put it in. So for our x squared, we're going to take the square root of it, and that's going to give you x to the first and x to the first, because when we take the square root of a variable with an exponent, you have to divide that exponent by 2. For our last term, you take the square root of 16, and we would get a 4, so we put a 4 and a 4 in there. And again, if you wanted to do your check, here you'd get a 4x, you'd get a negative 4x, and then they'd cancel each other out, which is exactly what you would want to have happen for these. So let's take a look at the next one. Again, two sets of parentheses. One's minus, one's plus. Does not matter what order they get put in. So for our first terms, my first term this time is a 121. So when I take the square root of that, I get an 11. The second term, take the square root, and we would get just a y. So 11 minus y and 11 plus y. The third one, this is one of the tricky ones. It's not dots, not dots. It's got a plus sign in the middle. It needs to be a subtraction. So this one's actually not factorable. It's a prime. Take a look at the next one. We're back to our subtraction just like we want. So I set up my two sets of parentheses. One's plus, one's minus. And then I take my square roots. So here I would get 2x squared, 2x squared. Square root of 9 would give me 3 and 3. All right, letter E, same thing. Even though it's got a fraction, which you guys don't like, it's the same steps. Square root of the first gives me x and x. Square root here, square root of 9 is 3. Square root of 16 is 4. So it's x plus 3/4 and then x minus 3/4. All right, then let's have you take a second and try the last one. So to check yourself, you should have gotten 3xy squared minus 7y and then 3xy squared plus 7y. So that's our dots. Those ones are pretty easy. If we take a look on the back, we have some special cases here. These are trinomials. We factored trinomials before. You guys already know the steps in the process. So we start with our two sets of parentheses. Signs here are the same. Again, that last sign right there, that tells me they're the same. That one tells me they're both going to be positive. So we got to look for factors of 144 that are going to give us 24 in the middle. And hopefully you notice 144, that is a perfect square. If we take the square root of 144, we get a 12. So if I put 12s here, 12 plus 12 would give me my 24 in the middle. So that's the special thing here. Now, one thing that they like to do is, since these are the same exact thing in the parentheses, they like to rewrite it as y plus 12 squared. So instead of writing y plus 12 times y plus 12, they rewrite it as y plus 12 squared. So let's try this next one. Same thing, only this time our signs are both going to be negative. This means they're same. That tells me they're both going to be subtraction. So x minus and x minus. And then we have to figure out what multiplies to give us 4 but adds to 4. And that would be 2 minus x minus 2 and x minus 2. So we would rewrite that as x minus 2 squared. Now when we go to look at this next one, set it up. Y minus, y minus. So our factors of 49, well, we only have a couple of choices. We have 1 times 49 and 7 times 7. Well, none of those are going to give us a 7 in the middle. So this one looks like the other ones, but it's actually not. This one's a prime one. You can't factor that one. So again, I want you to take a minute, try these 3 on the bottom here. So let's have you go ahead and check, see if you got those right. Take a minute. Letter D should have been y minus 12 squared. E was x squared plus 6 squared. And then F was x plus 8 squared. So again, these examples above, these are special trinomials. We call these perfect square trinomials. Because you always want to take the square root of that number at the end, and your signs are always going to be either both subtraction or both positives. So these are what we call our perfect square trinomials. We tell you that now because this is going to be important going into our next unit. You have to be able to recognize our perfect square trinomials. Okay, now putting it all together a little bit here. We've taught you 3 types of factoring. First one was GCF. Second one was trinomial, which is really kind of like a guess and check. And the third one we did today was our dots. We teach them in that order specifically because that's the order you should look for your factoring in. If you're given a problem and you're told to factor, you should always look first to see, does it have a GCF? If it does, then you take care of it. Then you look to see, is it a trinomial? If it is, then you factor using trinomial method. Then you look to see if it's a dots factoring. That's the order you should always look for it in. That's why we taught it to you in that order. So if we look at our first example here, I notice that they both have an x. So this one is going to be a GCF factor. So remember, we put our GCF out into the front of one set of parentheses, and then we go back up here and we divide by the GCF. So x squared divided by x gives us x to the first. There our x's cancel. So that's our answer, x times x plus 36. Over here, number 2, we look first, is there a GCF? And there's not. There's nothing that all 3 terms have in common. I know it's 3 terms, so that means it's going to be a trinomial factor. So I start to set it up, 2 sets of parentheses. X is going to be my first term. Again, looking here, your signs are going to be the same. This means they're both subtraction, so one's minus, one's plus. And then we got to think of our factors of 16. We have 1 times 16, 2 times 8, and 4 times 4. We're trying to get a 10 in the middle, so the ones that stand out to me are my 2 and my 8. So we always want to do a little smile, big smile. Negative 2x, big smile is negative 8x. Combine those, I get my negative 10x, so I picked correctly for that one. And then number 3, we want to look through, do they have a GCF? And they don't, there's nothing in common here. It's not a trinomial because I don't have 3 terms. And it looks like a dots, but remember, it's not because of this plus sign. So this one is going to be prime.